Hey guys, in this video I want to show you how to make a simple rocks explosions in Houdini, so let's dive in. So first let's add a new geometry node. You can dive inside, and here the first step is to add a geometry as an input. So in my case I'll use a spheres, but you can use any geometry if you want. So here for the settings of the spheres I will change the radius on the x-axis to something like 0.92. And I will keep everything else by default. I will change the primitive type to polygons, and here I will increase the frequency to something like 25. So now I want to add some displacement on these spheres to create our rocks shapes. So to do that, I'll add the mountain sop node. So here with this node, I will increase the amplitude to 0.5, and I will keep the noise type to simplex, but you can change the noise type if you want. So here I will increase the element size to 1.25. I will play with the offset just a bit. So in my case, I will put the value at 20.5. And here for the fractal, I will decrease the roughness just a bit, so I will put the value at 0.325. So now I have the base shape for the rocks, so let's add a new mountain node. In that case, I can add some tiny detail on these rocks. So for this new mountain node, I will change the amplitude, and in my case, I will put the value quite low, so I'll put the value at 0.09. And here I will keep the noise type to simplex, and I will decrease the element size to 0.25. And here I will decrease the fractal to something like 0.35. So now I will add a subdivide node, and here for the subdivide I will change the algorithm to open subdiv loop, and here I will put the depth to 2. So now I can convert these rocks as a VDB to remove this kind of flipped faces that we have at some part. So to do that I can add a VDB from polygons, and here I want to keep the detail of the rock, so I will use quite a low value for the voxel size. In my case I will put the value at 0.01. So now I can convert that rock back to polygon, so let's add a convert VDB node, and here I can convert it from volume to polygon. So now I want to create some kind of sharp edges on these rocks. So to do that I will use the pick node, and here for the pick node I will put a negative value, so make sure to keep the value quite low. In my case I will put the value at minus 0.05. So now let's add a smooth node just to smooth the topology slightly, and now we can convert these rocks back to VDB to remove this kind of flipped faces one more time. So to do that you can keep the VDB from polygons and convert VDB from the first step. So you can select these two nodes, press Alt and left click to copy them, and you can plug the smooth to the first input of the VDB from polygon. So here, as I want to keep the detail of the rock, I will decrease the voxel size just slightly. So in my case I will put the value at 0.05. So here I can add a VDB smooth SDF before convert it back to polygons. And here with this VDB smooth SDF, I can change the operations and make it to mean curvature flow. So now I can convert these rocks back to polygons, and I think for now it's very high res. So we can decrease the polygon number just by increasing the adaptivity mode slightly. So in my case, I will put the value at 0.01. So now let's add the last smooth node at the end. And for this smooth node, you can keep the attribute on position, and you can increase the strength to 25. So now let's add a null to specify this is the base for the rocks, and you can rename it base rocks. So now let's create the RBD simulations. So first we need to create some breaks on these rocks, and to do that we will use a node called RBD material fractures. So this node is a bit slow, but it's very nice as you can create some cracks on your geometry.
Most Houdini tutorials show you tricks. Very few teach you how to build real, production-ready setups from scratch. Artilabs is a premium Houdini training platform for artists who want production-level results, used in motion design, simulations, and high-end product visuals. You get 45+ hours of advanced content, including 2 complete courses where you build high-end animations from start to finish, exactly like in real client work. Every lesson includes full Houdini project files, so you're never guessing. You follow the exact workflow step by step. The library keeps growing every month. And right now, annual access is discounted with an extra 20% off for a limited time. Click the link below. Start building Houdini work that actually attracts professional clients.
So if you want to check the result, you can add an exploded view after the RBD material fracture. And here you can see it will create some cracks on the rocks. So by default, on the first fracture, we have 5 points. In my case, I will increase this to 12. So now we have a bit more pieces for the first fracture. So now if you want, you can go to the second fracture and you can increase the scatter point if you want. But in my case, I will keep it at 5, which is a number by default. So now to add some extra detail on the rocks, I can dive into the chippings tab, and here I can enable the chippings. So you can see it will add a bit more small pieces on the rocks. So in my case, I will increase the ratio to 0.7. I will increase the corner ratio from 0.5 to 1. And here I will put the directional noise to 0.15. So now you can add some detail on the inner faces on the crack, because for now everything is perfectly flat. So to do that, you can dive into the detail tab, and here you can enable the edge detail. So for now the resolution is quite low, so you can decrease the detail size just a bit to get a bit more resolution for the details. And in my case, I will put the value at 0.02. So now let's increase the noise height just a bit. So by default, the value is at 0.1. In my case, I will put the value at 0.15. So now everything is done for the RBD material fracture. So now let's say that we want to create little cracks before the explosions. So to do that, we can use the exploded view. So here we can change the uniform scale of the exploded view to something like 0.075. Of course, you can change this value at any time. So in that case, we can create this kind of cracks before the main explosions. So we want to enable these cracks with an attribute, with a gradient. So to do that, you can use the point VOP. So here with the point VOP, you can dive inside. And here I will use the rel bounding box node. So here I can split this vector into 3 different floats. So let's add the vector to float. And in my case, I want to create a gradient on the x-axis as my rocks is aligned on the x-axis. Of course, you can change the axis if you want, and you can even create your own attributes to create the fall-offs for the cracks. So here I will take my x attribute. Let's add a ramp parameter. And here for the ramp, I will put that to spline ramps. And now I can fit my ramp. So let's add a fit range. And here I can export an attribute. So let's add a bind export. And here for the name of the attribute, I will name it something like break rock. And I keep that on float because this is a float attribute. The value is going from 0 to 1. And if you want to check the result of the attribute, you can plug that to the CD attribute. In that case, you can get a preview of the attributes that we have created. So for now, we don't have anything. So you can go back to the sub by clicking on this. And now you can create your own ramps. And now you can see we can create a gradient like this. So in my case, I will put the ramp like this, and I will put the middle point at 0. And here I will change the ramp to monotone cubic to get something a bit smoother. And now if you want, you can go to the point VOP and you can promote the minimum value for the fit range. So here you can take this value, you can click on the little gear icons on the right, and you can click on promote parameter. In that case, you can control this parameter from the subs, and here you can make your animations. So now you can go back to the point VOP and you can disable the color attribute. So this is just for these. So now we want to create the cracks, but not for the entire rocks. We want to create the cracks only on the extremity of the rocks, and we want to remove the cracks at the center. So to do that, you can take a peak node just after the base rock here. So let's add a peak. So here for the peak value, I will put a negative value. So maybe we can put the value at something like minus 0.025. And here let's add a VDB from polygons. So here for the VDB from polygons, I don't want to get much detail, so you can keep the voxel size to 0.01. And now let's add a VDB smooth SDF. And here with the VDB smooth SDF, you can put that to Gaussians and you can keep the iteration at 4. So now let's convert that back to polygons. So let's add a convert VDB node. And here we can convert it from volume to polygons. So now we can create a group on our mains rocks based on these smaller rocks that we have created with the VDB. So to do that, let's add a group node. And here you can plug the first rocks on the first input of the group node, and you can plug that to the second input. And here for the group, you can change it from primitive to points. And you can keep the name on group 1. So here you can disable the base group and you can enable keep in bounding regions. And here you can select bounding object. In that case, it will create a point group based on the objects that we have created with the VDB setup here. So now let's give a value for the break attributes that we have created into the first point VOP, but this time for the point into the groups that we have created with the left part here. So to do that, let's add an attribute wrangles. And here for the attribute wrangles, you can create a value for the break attribute, but you can select a group for this. So in our case, we want to select the point group. So I will select my group 1, which is at the bottom of this. And now you can define a value for this break rock attribute. So F for float at rock, and this is equal to 1. So now let's add an attribute transfer. In that case, we can transfer the attribute to this. So you can plug this to the first input and you can plug this to the second input. So now for the attribute transfer, I will select my point attributes break rock. And here under the conditions, I will decrease the distance threshold. So by default, the value is at 10, which is quite low. So I will put the value at 0.01. So now let's blend the two positions based on our break rocks attributes. So we have the exploded view on this side and we have our base rock on the left side. So let's add an attribute wrangles. And here you can plug the exploded view on the first input of the attribute wrangles, and you can take the original geometry on the second input. So here to make the blend between the two positions, we will use the lerp functions. So to do that, we need to define a variables to control the blend between the two shapes. So let's create a float break rocks, which is equal to our @break rock attributes. And now let's get access to the point position of the first input and also on the second input. So let's create a new vector called p1 is equal to points. And here you can target the first input of the attribute wrangles with 0. You can type uppercase P for the positions and @pt_num for all the points. And now you can take everything, so you can copy that and you can paste it here. And you can change to P2 and you can target the second input of the attribute wrangles by replacing the 0 by 1. So now you can mix between these two positions. So let's add @p is equal to lerp. And here you can type P1, P2, and you can use our float variable here, break rock, so you can copy that and paste it here. So now I can go back to this point VOP and I can promote the maximum value for the fit range. So you can take the source max and you can promote this parameter. So now you can go back to the SOP and here you can animate this value. And you can see if I put a keyframe under this one, you can just blend to create this kind of cracks. So of course, it's up to you. You can use any mask for these gradients. But in my case, I will create the mask with the point VOP and I will animate the value right here. So here, let's say that we want to create the cracks from the frame 1 to the frame 48. And at the frame 48, we want to create the explosions. So here I will put the value at something like 0.15 at the frame 1. So I can click on Alt and left click to add the keyframes. And now I can go to the frame 48 and I can put that to 1. So now I can add a new keyframe to this with Alt and left click. So now we can do the RBD simulation. So first, let's add the RBD configure node. And here with the RBD configure node, we can initialize the active and deforming attributes. So we want the active attribute for the main explosion simulations, and we want the deforming attribute because we have animated our rocks on the SOPs with the keyframes that we have created with the point VOP. So as the geometry is animated on the SOP, we have to enable our deforming attributes. So here we can put that to 1 and active to 1. So now let's add the RBD bullet solver. And here we can disable the constraints and also the proxy geo. So here for the RBD bullet solver, mostly everything is by default. You can just go to the first tab and you can disable the gravity. So now, like we said before, we need to animate these cracks from the frame 1 to the frame 48. And at the frame 48, we want to create the main explosion with the RBD bullet solver. So to do that, we need to tweak the active and deforming attribute before the RBD bullet solver. So to do that, let's add an attribute wrangles. And here you can rename it something like deforming attributes. So here we want to set the deforming attribute at 1 until the frame 48 and at 0 after the frame 48, as we have animated our rocks until the frame 48. And then we want to create the main explosion with the RBD bullet solver. So to do that, you can type if frame is over 48. Then we can define our deforming attribute. So you can type at deforming is equal to 0. And then you can type else. And here you can type at deforming is equal to 1. So don't forget to close the curly brackets. So that means we get our deforming attribute at 0 over the frame 48 and the deforming attribute is equal to 1 before the frame 48. So we need to do the same, but this time for the active attribute, and we need to reverse that. So here you can copy and paste the attribute wrangles and you can rename it something like active attributes. And here you can set the active attribute at 1 over the frame 48. So you can replace the attribute here. You can type active and this is equal to 1. And before the frame 48, we want to set the active attribute at 0. So you can replace the attribute name by active and you can put that to 0. So now let's dive inside the RBD bullet solver to create the forces. So to do that, I will add a SOP solver. So here I can dive inside and I can add a point velocity to my DOP geometry. So let's add a point velocity. And here for the point velocity, I will go to curl noise. I will add a curl noise velocity and I will disable the animated noise. And here I will increase the scale at 2. So now we want to animate these forces only at the frame 49. So let's add enable solver. And here you can type $ff is equal 49. In that case, the forces will be enabled only at the frame 49. So now let's add a pop drag. And here with the pop drag, you can keep the air resistance at 1 by default. And here I will also recommend you to add a pop speed limit. In that case, you can reduce the spin for some pieces. So in my case, I will set the maximum spin to something like 4. So now you can go back to the SOP and you can put this geometry in cache. So let's add a file cache node. And here with the file cache, you can rename it something like RBD explosions. So you can change the file path to explicit and you can put that under the cache folder and under the $OS folder. So here you can put that in cache for 120 frames. So you can remove this one, right click, delete channel, and you can replace the value with 120. So now you can click on save to disk. So the simulation is done and now you can check the preview of the simulation. So we have the crack starting at the frame 1 until the frame 48. And at the frame 48, we have the explosion of the rocks. So now if you want, you can add the rest attribute for the shading. And now you can add the null to specify this is the output for the rocks. So you can really mix out. So that's it for today, guys. I hope you enjoyed it. You can get access to this project file with the link in the descriptions. I'll see you in the next one. Bye bye. That's it for today, guys. You can check out our website to get some premium courses, tutorials, project file, Houdini tools, and more. So check it out with the link in the descriptions.